Now let's consider properties of exponents. For now, we'll again consider only positive integer exponents. Informally, positive integer exponents denote repeated multiplication. For any real number a and positive integer n, a to the nth power means a product of n factors of a. For example, 2 to the third power equals 3 factors of 2 multiplied together. 3 to the fourth equals 4 factors of 3, which gives 81. Similarly, the fraction 2/3 raised to the fourth power means 4 factors of 2/3, and to multiply fractions, we multiply the numerators and denominators to produce 16 over 81. Let's review the laws of exponents and then follow up with a variety of examples. The first law states that when we multiply like bases, we add the exponents. The second law states that to divide like bases, we subtract the exponents in order of top exponent minus bottom exponent. To raise a power to a power, we multiply exponents. To raise a product to a power, we apply the exponent to each factor. And finally, to raise a quotient or fraction to a power, we apply the exponent to the numerator and to the denominator. We might comment here that exponents do not distribute over sums or differences. Now let's consider some examples to illustrate these properties. Instructions on such problems will likely be to simplify the exponential expression. 2 cubed times 2 to the 8th equals 2 to the 3 plus 8, which equals 2 to the 11th power. To simplify, a to the 5th b squared times a b to the 7th. First, notice that the 7th power only applies to the b in the second factor. Now we can reorder the factors using the associative and commutative laws of multiplication to get a to the 5th times a multiplied by b squared times b to the 7th. And then we get a to the 5 plus 1 power times b to the 2 plus 7 power, which yields a to the 6th times b to the 9th. To compute x to the 8th over x squared, we subtract the exponents to get x to the 6th. Now consider the quantity 2x cubed. One way to think about this is as 3 factors of 2x. Then we can reorder and regroup the factors, yielding 2 cubed times x cubed, which produces 8x cubed. Notice that we could have used the laws of exponents dealing with raising a product to a power and skipped a few steps. Consider 5x all squared. If we apply the exponent to each factor, we get 5 squared times x squared, which simplifies to 25x squared. For x squared quantity cubed, one option is to rewrite as 3 factors of x squared and to add the exponents, which yields x to the 3 times 2 power, or x to the 6th. Notice we could have simply used the law of exponents directly that says to raise a power to a power, we multiply exponents. So b to the 5th cubed yields b to the 5 times 3, or b to the 15th in fewer steps. Finally, 1/2 cubed can be computed by applying the exponent in the numerator and denominator to get 1/8. Now let's consider a few more complicated examples. Again, the directions will be to simplify each expression. A to the 8th b cubed times a to the 4th b can be rewritten by reordering and regrouping the factors involving a and the factors involving b. Then, to multiply like bases, we add the exponents. Notice that the factor of b is really a factor of b to the 1st power. We get a to the 12th times b to the 4th as a final simplified answer. Now consider a fraction with numerator 12 times x to the 10th times y to the 7th and denominator 4 times x cubed times y. We can break this fraction into the product of 3 fractions because multiplication of fractions multiplies numerators and multiplies denominators. Now we can simplify each fraction separately. Notice that 12 over 4 is 3, and to divide like bases, we subtract the exponents. This simplifies to 3x to the 7th, y to the 6th. In 2x to the 5th quantity cubed times 3x to the 4th, we need to deal with the outermost exponents first. The 3rd power applies to both the 2 and the x to the 5th. Then we can reorder and regroup our constants together and our powers of x together. This produces 24x to the 19th power. Notice that the 19th power only applies to the factor of x and not to the coefficient 24. Finally, consider the fraction 4x over 7 quantity cubed. We apply the power to the numerator and denominator and apply the power to both factors in the numerator. We get 64x cubed over 343. Note that it is useful to have several powers of single-digit numbers committed to memory so that you won't have to use a calculator on every problem.